All right, so if you look at the schematic of the board that we are building here, and you kind of zoom in on the address bus, it might be a little perplexing here, right? So here's my 68K. I have my address bus A0, A1, A2, all the way up to say I can't remember if it's A18 or 19. It's a bunch of address bus lines, right? And each one of those address bus lines is going both to a flash chip and also to a RAM chip. Okay, so A0 on the 68K goes to A0 on the flash, A1 goes to A1 on the flash, and so on. But A0 also goes to A0 on the RAM, okay? And A1 on the 68K goes to A1 on the RAM too, right? So these devices are hooked up basically like in parallel with each other. Okay, so what that means is that the flash and the RAM both get the same address on every bus cycle. That's kind of weird though, right? I mean, it doesn't really make sense because we don't want to put them in the same address space. Okay, so what we really want to do here, if you look at a memory map of this thing, I'll draw it like this, I guess. You know, I'll put address 0 on top. Okay. And so what I'm going to do is I want to have the first address spaces starting at address 0. I want those to be flash address spaces because this is where the program is going to start executing. The CPU always starts executing code at address 0. And then above the flash, I want the RAM to be located at a different memory space, right? At different addresses in memory, say 80,000, something like that, okay? So this would be 512K. This would be 512K for this board that we're building. But the problem is, this doesn't seem like we've hooked it up this way, right? It seems like the addresses that we're giving off to our flash and our RAM chip are identical to each other. So how can we address flash in one region of memory and RAM in a different region of memory, right? It seems like every time we go through a bus cycle, we're going to get one value reading from the flash and one value reading from the RAM, okay? That doesn't seem right. So that's not actually what's going to happen, right? But it does kind of seem that way, right? So really, the way we're going to make this distinction between the flash and the RAM chips, right? So the way we're going to be able to tell, you know, if the CPU is trying to access a region of memory, you know, in flash versus in RAM, is we're going to look at the higher order pins on the address bus, okay? And we're going to be able to tell based on the higher order address pins if we're talking about a flash address or a RAM address. Okay, so here's how we're going to do that. So if you look at an address, right, we have, well, let's see here. So we have 19 address pins that are going to each flash and RAM, right? And so let me draw those out here. Okay, so this is A0 and this is A18. Okay, and A0 through A18 are both hooked up from flash, both hooked up to flash and to RAM, okay? Okay, so the flash addresses are going to be all zeros up through all ones, right? Okay, so this is 0, 0, 0, 0, 0 through 7F, F, F, F. Okay. And at the next address above 7F, F, 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 right? This is hex. This is binary. Okay. So if we add 1 to 7F, F, 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 we get 80, 0, 0, 0, 80,000. Okay. And so that would be 1, 0, 0, 0, and then like this. This is the first address, this 80,000 address here. This is the first address in RAM, okay? So if we look at this, right, we have A0 on the bottom. We have A18 on the top here. And this is, so A0 through A18 are wired both to the flash and to the RAM. A19 kind of tells us if we're talking about a flash address or a RAM address. Okay, so if A19 is a 0, then we know that we are talking to a flash address. Okay, if A19 is a 1, we know we're talking about a RAM address. Okay, so but A19, the pin A19 comes from the microprocessor. There's an A19 pin on the microprocessor. It's just not wired up to the flash or the RAM. Okay, so what we're going to do here is we're going to use the A19 pin to enable or disable the different memory devices. Okay, so here's how we're going to do that, right? The memory devices have kind of like a couple of different inputs on them that tell us if we're able, what we're doing here, right? We have a chip enable input on both of them. We have an output enable input on both of them. And we have a write enable input, right? These are all active low. I can't remember if the flash has a write enable input or not. I'll just write it on here. I think it does, but I think it's not used for the thing that we normally would use it for, right? So you have chip enable, output enable, write enable, okay? So what we're going to do is when we see, so chip enable basically tells us if we're able to, if we're talking to this chip or not, right? Output enable is like the read signal, okay? So chip enable says, should this chip actively process this bus cycle, okay? So if chip enable is a 1, then that means that this chip should ignore the bus cycle. If it's a 0, that means it's active. Chip enable is active low signal, right? If chip enable is a 0, then that means that this chip will respond to this bus cycle, either by, if it's a read cycle, it'll output the data onto the data bus. If it's a write cycle, it will latch the data from the data bus into its internal memory, okay? So chip enable tells us if the chip should respond to the bus cycle at all. Output enable tells the chip if it should output the data onto the data bus, okay? So in the case of the RAM, well, in the case of the flash, we're only ever going to be reading from the flash, right? So chip enable and output enable should, if chip enable is active, output enable should always be active when chip enable is active, okay? In the RAM's case, we could read or write to the RAM. If chip enable is a 0, okay, and output enable is a 0, then that means that we are doing a read cycle, right? If they're both 0, that means they're both active. So the chip is enabled and should respond to, the chip enable 0 means that the chip should respond to the bus cycle. Output enable 0 means that we're doing a read cycle, and we should read the data from the internal memory and output it onto the bus, okay? If chip enable is a 0 and output enable is a 1, then we're saying that we're going to respond to the bus cycle. Chip enable is 0 means we're going to respond to the bus cycle, but output enable is disabled, right? Output enable is an active low signal. So if we say output enable is a 1, then that means that we're telling the chip it should not drive the data bus, right? So this is going to be used, chip enable 0, output enable 1 is going to be used for write cycles to the RAM, okay? In the case of the flash, the only way we can do this is chip enable will be 0 and output enable will always ever be 0. If chip enable is a 1, output enable will always be a 1, okay? Okay, because we should never write to the flash. Okay, good. Okay, so basically what we're going to do is we're going to use this A19 pin on our address bus to decide which of our chips we should chip enable, okay? So so basically what we're going to do is we're going to look at A19, and depending on the value of A19, we're going to set the chip enable and output enable pins for the flash and for the RAM. Okay, and this whole process of deciding which chip gets to process the bus cycle is done by a circuit called an address decoder. There's different ways of making address decoders, but the most sensible way, I guess, is using a thing called a 74LS138, or you could use a 74HC138, whatever. You know, this internal. These two letters here just tell us what kind of transistors it's made out of, right? So we don't really care what those are. The 74138 is a decoder which takes 3 inputs, we'll call them A, B, and C, okay? And it generates 8 active low outputs, okay? So it can, basically what it's going to do is it's going to look at these 3 inputs and it's going to decide if they're all 0, then let's say A, B, and C are all 0, 0, 0, then what it's going to do is it's going to only enable one of the outputs. Okay, it's going to only enable the output, I think it's called Y0. All right, if A, B, and C are, I can't remember if it's reversed or not. Let's say they're 0, 0, 1, then it's going to enable Y1. Okay, and so on. Right, so we take a binary encoded input on A, B, and C, and we generate a one-hot output. This is called a one-hot output, where only one of the output lines is active, right? And the activity level is low, right? The reason where they're active low is because the chip select signals on our memory chips are all active low. Okay, so what we're going to do here is we're going to hook A, B, and C up to I think it's A19, A20, and A21. Okay, and we're going to read the values on A19 and A20 and A21, and we're going to use those to chip select the flash, the RAM, and then if we have other chips on there, like let's say we have a serial port, or whatever other peripheral chips we have on our board, we'll probably add some more peripheral chips to this thing, then we'll use other outputs of this 74138 address decoder to chip select those. Okay, we're going to start working on the address decoder now. So the first thing we're going to do is mount the 74138. That's this guy here. I'm going to put it right there. We got the CPU, right? We want to keep things as close as possible, obviously. So we got our CPU here, and basically we're going to run address lines 19, 20, and 21 over here to this 74138, which is going to generate our ROM select and RAM select signals. And those ROM select and RAM select signals are going to be run to the chip enable on our ROM and our RAM, and chip enable is pin 22. I think that's approximately right here and right here. So we're going to keep our address decoder circuit kind of down here close to the chip select signals on our memory devices. Okay, so we got a 16-pin dip. I'm getting a couple of capacitors out here because we're going to need decoupling caps for a couple other circuits in our address decoder, which we'll mount in a little bit. We're going to use an OR gate, a 7432 OR gate, and also a 7404 inverter, or NOT gate. Here's our decoupling cap for the 138 though. So this is pin 16. Here. Alright, so this is pin 16 on my chip, and I'm going to connect my, so here's pin 16, that's VCC, and I'm going to connect one of the pins of this decoupling capacitor to pin 16, not using like a regular piece of wire, but I'm just going to use one of the leads on the decoupling cap. I'm going to string it over here like that. Nice. Want to make sure we don't short the two leads of that thing together, because that would be bad, obviously. Cool, so there's my power connection to pin 16. Now I just need a ground connection to my decoupling cap here. Okay. Oh, there we have it. There's my power and ground. Oh, you can't see that. There's my power and ground for my decoupling cap. And now all I need to do is run, let's see here, my ground is going to be on pin 8, so that'll be right here. So here's pin 8. I have a solder tack on that already. So that's going to be my ground supply for the 138. Nice. Okay, got my ground there, looking good. Okay, so let's run my address lines. It's going to be 19, 820, and 821. And those are going to go to pins 1, 2, and 3 on this guy right here. 1, 2, and 3. Okay, so A19 is going to be on pin 51 here. That's going to be right there, pin 51. I'm going to go to pin 1, or A. That'll be right here on my 138. Okay, 820 is going to go to pin 2. A20 is pin 52 on my processor. I don't know if you can see it. Yeah, you can't really appreciate it from where that camera's sitting, but this is a tight squeeze in here. And I want to be careful when I solder this guy. And I'm not going to melt any of the insulation on any of my other wires that are right next to it here. So I'm going to be real careful with this. I'm lucky that the insulation, the wire I chose, this blue wire I chose for the data bus, is insulated with silicone. And I found that it melts at a really high temperature. So fortunately for me, I don't have to worry too much about melting that stuff, but the insulation on the other wires around there, especially this red wire and the orange stuff that I'm using for the address bus, I don't know how forgiving that's going to be. All right, that's A20. That's going to go over to pin 2 right here. Here we go. Don't want to There we go. It'll stay in there. Well, maybe it won't. Okay, that's A20. Going over to pin 2, which is B on my 138. Then I got pin 53, which can't really see it there. Let's see. So pin 53 is right underneath this red wire, this red power wire here. So that's going to be a challenge to access. This is my A21 line. Okay. That's pin 50. Did I say 53? It's pin 54. So this is my pin 54 right here. So, well, I'll just have to do my best, I guess, and hope I don't melt too much insulation while I'm getting in there. Probably if I were to do this again, I would probably leave a little bit more slack on some of these wires. And I think I would also use thinner wires for some of this power stuff that I ran here, because it's not very flexible. If this short little power wire that I got to move out of the way, it's going to be hard to move because it is solid, stiff wire. Whoops. Got to be real careful here. Yep. Okay. I'm not exactly certain how I'm going to get a soldering iron in there. Would have been a little easier if I would have left myself a little more slack. See, I can get my tweezers in there, but I don't know if I can get an iron in there, because I think my tip of my iron is a little bit bigger than my tweezers. Let me see what I can do here. Yeah, I'm afraid I'm gonna melt that insulation on that thing too. That's the other thing about it. And that power wire, it's right next to it. There we go. I might have done it. I might have. I managed to short a couple of these things together here, but maybe let me just get this solder blob out of the way. Let me see. Well, it's stuck in there. It's pretty hard to see what's going on, though. See, one thing I want to do here is make sure that I don't have a short between this address line A21 and my 5-volt bus. So I'm going to use my ohm meter. Now I'm going to measure resistance here. I just stick the two terminals together and I'll have less than an ohm. So what I can do is put one of my terminals on my 5-volt bus, and then I can clip this wire the length that I'm going to use. Strip a portion of it off here. And then I can check to see. Yeah, you just want to make sure that we don't have, yeah, you can see I have 4.3 megohms. That's good. That means I don't have continuity. If they were shorted together, this is what it looks like when they're shorted together. So I'd have like less than an ohm. I don't think they are. So somehow I managed to make that solder joint work. Anyway, I would recommend, if I could give myself some advice in the past, I would definitely recommend that I give a little bit more slack on some of these signal wires. And probably use thinner gauge. I'm using 26 gauge wire for the power. I'll probably use thinner gauge wire on the power. Maybe I would use this 28 gauge or 30 gauge wire on the power. That would probably be fine. The thicker the wire, the more current it can carry, of course. So that's usually people try and make their power wires thick. But in this case, I think it turned out to be kind of a liability for me, just because it's so difficult to solder. Well, it's an acceptable joint. It's not great, but it's gonna have to be good enough. Okay, so there's my 3 address lines from my address decoder. It looks like I left a little too much slack on this guy, but I'm just gonna leave it the way it is. Not proud of myself, but it's gonna have to be good enough. Now we're gonna tie the output enable pins active. So output enable 1 on pin 6 is going to be tied to 5 volts, and output enable 2A and 2B on pins 4 and 5 are going to be tied to ground. Okay, so 4 and 5 are going to be tied to ground. And let's do that. I'll use this black wire for that. Oops. And what I can do here, I can just short 4 and 5 together with a short little stub of wire. One of the trimming pieces that I trimmed off of my capacitor or something. So I'll just short those 2 things together there. There we go. Looks good. 4 and 5. And we'll tie both of those to ground. Now, if I was doing this with a printed circuit board, I might use a resistor here to tie these guys to ground. But in this case, we'll just tie them directly to ground. Oh, man. Okay. That thing doesn't want to. There we go. That'll work. I guess we could just jumper this over to my other ground pin over here. Let's do that. And we don't have to run a bunch of long wires over to the main ground bus. Let me trim that a little bit. Okay, that'll work. There we go, looks good. Okay, now pin 5 is going to go to pin 6 is going to go to 5 volts. 1, 2, 3, 4, 5. That's pin 6 right there. That's going to 5 volts. Okay. All right, that's a nice little run of wire over to 5 volts there. Okay, cool. Okay, so now we're going to tie Y0 and Y1 up to the ROM select and the RAM select. So Y0 is going to be on pin 15. Okay, so here is 16 VCC. This is pin 15 ROM select. Okay, and we're going to tie that over to the chip enable pin, which is 22 on the ROM. Okay, so let's get after it. We will use white for the control signal, right? We're using white for all our control signals on this board. Okay, so that's going to pin 22. All right, so this is a 32 pin socket, so this is 16, 17, 18, 19, 21, 22. So that is the 1, 2, 3, 4, 5th one up away from the processor. Okay. So 17, 18, 19, 21, 17, 18, 19, 20, 21, 22. Right, it's an empty pin between the data bus and the address bus right here. If you can see that, that'd be pin 22. That's chip enable. So let's bring that over there. Cool. I'm gonna try. What I'm gonna do here is I'm actually gonna try and fish this underneath the data bus. Let me strip it first. I'm just gonna fish it under the data bus here. And then bend the pin, bend the end of the wire. So we'll go to that hole. And there we are, right here. Looks pretty good. See if I can get it to sit in there a little bit nicer though. That's the only thing. I think I might want to trim the end of that wire just a wee bit too. just put it right on there. Now I managed to short a couple of pins. Okay, I think I had a solder blob there that shorted a data pin over to that chip enable wire. But I think that's a decent joint there. I think that's gonna work. So that's my chip enable for my ROM. Now I want to do chip enable for my RAM. That's gonna be Y1. Y1 is on pin 14. So here's Y1. It's going to be RAM select. I'm going to run this over the same place, pin 22 on the RAM. There we go. Right there. That's it right there. Nice. So I managed to keep these wires pretty short. They could have been a little shorter. You know, shorter is always better here when you're doing these things. Especially for these high speed. You know, this is going to be a fairly high speed bus here. So really, the shorter the better. Cool. Okay, that's my chip enable for my RAM. Okay, looks good. So now what I want to do is connect my write enable pin and my output enable pin for these things. So we'll do the output enable pin first. The output enable pin is going to be active low whenever the processor is attempting to do a read. Okay, so it's trying to read from memory, then output enable is going to be active. Okay, so this is like the read signal. Okay, so we're going to go through, we're going to use an OR gate, which is a 74LS32 or a 74HC32. And we're also going to use an inverter or a NOT gate, which is I believe it's a 7404, to generate our output enable signal. Let's see here. Now we can put that right here. So here's this can be my inverter, I guess. This will be my inverter. Now what we'll do is grab a capacitor, which I just got out for this guy. Here's my 5-volt pin on, what is it, pin 14 here on the 7432. So we will connect a capacitor there from 5 volts over to ground. Now I need to connect it to the 5-volt bus. There's my 5-volt bus right there. Ground's gonna be pin 7. Right here, I believe. Yep. Can't get that wire to, oh, no. Now I got that wire to go in the hole. It's just too thick. Okay. All right, we got power. Now we need to run ground to that capacitor. Looks good. Okay, we got power run here. All right, so now we need to hook this inverter up. Well, before we do that, let's hook up power to this OR IC here, this OR gate thing we got. I'll put it, boy, I don't know. I like to put it right next to it, but I don't know if I'm gonna be able to. Let me see. No, I can't. Wish I would have placed these things one. Oh, there we go. Hang on. Yes, that's what I want right there. Okay. Okay, so this guy I can do here. Well, you know what I think I'm gonna do? It's gonna put this cap right across VCC and ground buses. Then I don't have to run any wires for it. So here's my 5-volt bus on the outside here. Okay, and then my inner bus, that's this I-shaped thing, this is my ground. So I'm just gonna put my cap right on these 2 holes that come out of my 5 volts and my ground. I don't have to worry about running any wires over to it. Just need to tack this IC socket down here. You know, I could have gotten away with that on that other decoupling cap that I put in too, but it's okay. Okay, good. Now, here's my power pin here, pin 14. I'm gonna run that over to VCC. And we'll do the same for ground. Ground's on pin 7. Right there. Okay. Real nice. Feel good about that, for sure. Okay, so let me label these guys. with a marker real quick here so we don't forget what's what. So I'll say the one on the inside is going to be the 32. And the one on the outside is going to be the 04. Okay, so, you know, you can see I just put some black marker there to label them. Normally we probably wouldn't have to label these if you're doing it. The reason I'm going to do this is, probably the better thing to do would just be to stick the actual chips in those sockets before you solder them, so that you can always look at the numbering on the chip to see what kind of a chip it is. But I actually forgot to buy these chips, and so they are coming in the mail right now, but they're not here yet. So I don't have any chips to stick in those sockets right now. So I'm just going to have to label which is which. Okay. Okay, so so let's generate the output enable signal first. Okay, so what we're going to do is we're going to bring from the read-write not line on the CPU, we're going to come into an inverter. Okay, so that's going to be pin 1 of this 7804. And then the output of that inverter is going to go to the input of an OR gate here on the 7832. Okay, so let's get after it. So read-write not line is on pin 10 of the CPU. So we're just going to bring a white wire from pin 10 of the CPU, read-write not, over to the input of our inverter. So I believe this is pin 10 right here. Yep, it is. So that's my read-write not pin. There we go. Put our wire to that. There we go, looks good. And then that's gonna go over to pin 1 of my inverter, which is right here. Pin 1, it's gonna be this guy. Okay, so that'll be the first one on the inside right across from VCC. That's my pin 1 input to my first inverter. Okay. Okay, so we'll route this thing kind of gently here, like this. Give myself a little bit of slack on this guy. And I'm going to actually run it underneath these other bus signals here, just to try and keep things as neat as possible. Huh? Looking good. Yeah, that's pretty good right there. Okay. All right, there's my read-write not. And I'm gonna take the output of read-write not, which is gonna be on pin 2, bring that to the input of one of my OR gates. It's gonna go to pin 1 on this OR gate, the 7432 right there. Inverse of read-write not coming here, and then we're going to take lower data strobe and tie it to your lower data strobe is going to be pin 9. We're going to tie that to the second input of this OR gate here, and that's going to generate our output enable signal for both memories. There we go. Okay, so there's my my lower data strobe. So that's going to be low whenever the processor is asserting an address onto the address bus. Okay, so if lower data strobe is low and read write not is high, then that means that we want to assert output enable low. I believe output enable is going to be the third pin. It's going to be the output of that OR gate. So I think it's going to be the third pin on that OR gate. Let me check. So I believe this is 22. I'll just check again here. So this is 17, 18, 19, 20, 21, 22, 23, 24. There's 24 on my RAM. 24 on my ROM is right here. So I'm going to take this guy, probably just string it over here. Do that. Now this is definitely a scenario where I wish I had some thinner wire here, because it's going to be real hard to get 2 pieces of 26 gauge wire on this one pad for pin 24. I can tell you that. That's going to go here. Pin 24. Yeah, I think I'm going to try this though. Put one of them in the hole next door to it. And I'm going to short the pin over there to that hole, just to make sure I have some mechanical stability. Because grouping those 2 wires on the same pin, I feel like it's gonna fatigue off really easily. And in my experience, it's extremely difficult to find problems like that. When a wire fatigues off, you are up the creek, buddy. Pretty much. Okay. Okay, so here's my output enable. It's going to 24 on my ROM. Be right there, I believe. Let me just check. Yeah, that's it right there. Alright, that's not the greatest work I've ever done there. It's too big, I think. There's too much slack on this guy. I'm gonna just cut it a little short here to get rid of some of that slack. That's a decent joint. I don't know if you can see that or not. That'll work, I think. It's becoming progressively more difficult to make good quality solder joints on this thing as the board gets more and more crowded. I can tell you that for sure. Okay, so there's my output enable circuit. So we've got the address decoder, which sets chip enable independently for these 2 guys. We got output enable, okay? And then the last thing is write enable. So write enable on the flash device is going to be tied inactive or high. Okay. That'll be pin 31 on my flash. Just going to tie that directly to VCC. Okay, so turns out we got a VCC pin. Here's my VCC on my flash, and right next to it, this is pin 32, right next to it is pin 31, right enable. So we'll just short those two together with a little stub of cutoff wire. If I can find, got quite a bit of cutoff wire here. I just gotta find, I don't know if that's a good joint or not. Just gonna make sure that's, yeah, okay. There we go. That looks pretty good, I think. Yeah, I think it looks good. Okay, and then the right enable on the RAM is gonna go to read write not. Okay. So that'd be pin 10, goes over to here. So we'll probably just grab it from here and bring it over there. Which is unfortunate because we need to get to solder two pins. So they'll be on pin 1 of my 7404. It's this guy here. There's pin 1 right there on top. Okay. We can do this kind of we can do it in two ways, right? We can wire read write not up here in one of two ways. We can either go from pin 10, I believe this is pin 10. No, it's this one. One of the other here, and bring it over this way. Okay. Or we can go from here and bring it over this way. So I am inclined to reduce the amount of congestion over here by the CPU. So I'm gonna bring it from over here. I already got a lot of congestion over here by the CPU, a lot of wires going in and out in different places. So I am going to bring it from pin 1 of the 7404, which is right here, right? Okay, here's my pin 1 of my 7404. Now I have two of these big, thick 26 gauge wires that are both gonna be trying to stick into the same pin here on pin 1. So I'm not sure how we're gonna manage this exactly. I may have to do something similar to what I did last time and just tie one of them to the neighbor. I think I am gonna do that. So I'm gonna hook one of them up to a joining pin here. Okay. And then I'm gonna short them together. Whoops. There we go. Nice. Okay. So I am now gonna check continuity here just to make sure that I have a good solid connections between my read write not line on the processor and the read write not lines on the flash and the RAM. Excuse me, on the RAM. Okay, so it's gonna be, let's see here. Oh, this is, now the problem was I wasn't on the right pin. Okay, so here's my connection to my inverter. Good, I got continuity there. And here's my connection to my, there you go, to my RAM chip. I got continuity there. Okay, I'm happy. Very good.